I'll get started. Hello, everyone. My name is Shelley Verplug, and I'm very happy to be moderating this session on measuring the retail food environment and analyzing its effects on consumers. We have a great program here today. We've got 4 papers that are going to be presented. The first one is by Ben Sheridan of Colby College and colleagues. He's looking at different measures of boundaries of measuring the food environment. And this is work that he's doing with myself and with Chris Dickin, who's at USDA. Our second presenter is Chen Zhen from the University of Georgia. And I like to call it Chen and the Formers, because everyone else in his, except for Sean, has former affiliations. So we'll call him Chen and the Formers. It's a good name of a new band that we're putting together. Chen is estimating, using the Food App Survey to estimate a complete food demand system and to simulate the responsiveness of consumers to different policies, such as fruit and vegetable subsidies and taxes. Our third presenter is Ricky Volpe from Cal Poly San Luis Obispo. Ricky and his co-authors are interested in historical data on the locations of stores and how the trajectory of changes in the food environment impacts food outcomes. So we're looking forward to that. And then our fourth presenter is Mary Muth from RTI, and she and her colleagues are presenting some really important work that will help measure the food retail environment, using the IRI info scanner data, looking at things like estimating weights and mapping codes to data sources, and then constructing price indices. And all of these presentations have a measurement bent to them, and they're all trying to measure the food environment in a way that will help us do further research on understanding how the food environment impacts food and consumer outcomes. So during the session, all the presenters will be getting 15 minutes to speak. I will be sending emojis to you to tell you when you get close to time. I'll give you a open mouth look when it gets down to 3 minutes, and then I'll start crying when you go over time. So look for those from me, and if you don't see them, I might just start crying and let you know that your time is up. And we hope to have some questions at the end. I think with Zoom, it might just be easier to save the questions for later. But if you have something that's really important that you need clarification on, put it in the chat box, and I'll try to moderate that. So this is testing my Zoom capabilities, so please be patient with me. So first off, we have Ben Sheridan from Colby College.
Thanks, Shelley. Let's share. All right, trying to share the screen. Apparently, okay. Well, I tried to share.
I've got all your slides too, so I can't.
Sure. If you want to, well, Zoom's telling me it won't allow it to record and share my screen unless I quit Zoom. So I don't know what preference that is, but I don't know. Yeah, so I don't know. Maybe if you want to.
Sure, I think I.
Sure.
Looks like I'm sharing the screen, and this is your presentation, right? All right, let me go to the slideshow. And I'll follow along.
Sure, sorry.
Can everybody see that? Give me a thumbs up or a...
Yes.
Okay, great.
Perfect. Yeah, so as sort of Shelley said in the beginning, what we're looking at in this project is sort of, does the boundary definition matter? Essentially, when we look over the cross of a lot of the food environment studies that have been done in the past, the boundary definition varies. And the question is, I think that could be a main reason as to why some of the consensus on what measures matter or how those measures are specifically defined matter. So in general, the roadmap of the paper, I'll mention again, but Shelley mentioned it. This is with Chris Dickin, who's still in the OCA, and Shelley, who's now at GW. So the general roadmap of this is to ask sort of two main questions. One is in this first part. The second question will be sort of in the future, being in the next couple months or so. But do traditional metrics used to measure the food environment differ by boundary definition? And if so, are they statistically significant? Then the next question that would follow from that are the food environment measures robust to outcomes that we think about in terms of diet quality, obesity, or other outcome measures that we might want from there. So the way that we think about, we approach answering these questions is to define food environments for the same households, the same sort of area, in 5 different ways, and then calculate their measures within each of those 5 different boundary definitions. So we do a census tract, 2 service area methods, and then 2 Euclidean distance methods. Yeah, and in general, we find that census tracts are pretty limited in terms of how many proportions of events and expenditures are purchased in there. And then service areas are essentially the most interacted with, I guess, but we'll define those terms moving forward. Perfect. So as all of you know, right, the food environment is multidisciplinary, and just sort of 2 ways that it's thought about in terms of the public health of a community's exposes consumers to different levels of healthy and less healthy food, and that might incentivize your choices. Whereas from an economics angle, we might think it's more around supply and demand of, well, if there's demand for a certain type of good or there's oversupply of that type of good, then you'd be more likely to influence your choices as well. I guess in addition to these 2 ways, there's many other ways to think about the food environment, and that's led to a couple calls, but I just cite one in terms of Caspi et al. To standardize and validate measures that are used throughout these things instead of having a multitude of papers use different types of measures. And so to answer sort of this call requires 2 things or 2 ways of addressing geographic problems. And on the next slide is the 2 sort of geographic problems that this brings up. The 2 fundamental geographic issues is sort of what's called the modifiable aerial unit problem. And this occurs in any study when we divide non-overlapping aerial units, and you can do it in a variety of ways. So this was first considered pretty early on, right? The term was only coined in 1980, but the problem was thought of right 1930. And it's mostly across the geography literature studied in geological studies, thinking about watersheds or hydraulics, other things like that. And not, at least that I found, a ton in practice with food environments. But we can imagine how if deciding on a census tract measure with buffers or a distance from home or other things would certainly suffer from a modifiable aerial unit problem, right? And the second fundamental geographic issue is what's called the uncertain geographic context problem. And slightly different from how we define the aerial unit is we're unsure how the individual interacts with the unit that we defined, right? And so even once the geographic unit is well defined, we're unsure how the individual interacts with that unit. And so if we're thinking about that in terms of a census tract example, or we'll see that through, we claim, right, this boundary is the food environment, but we don't often necessarily get to see directly how the individual interacts with that food environment before we sort of test those outcome measures. And so one study, not necessarily related to the food environment, but looks at these space delineation definitions, is what Zhao et al. Calls them. And they think about the uncertain geographic context problem in relation to obesity in terms of thinking about, should I define the environment around work, the home, place of exercise, right, recreation, rather than just purely deciding it's closest to the residence. The way that I see this specifically presenting itself in the food environment is first in terms of boundary measurements. there's a couple that we list here in terms of administrative, thinking about a county, census block group, census tract, proximity measures in terms of almost always distance from the home, let them vary by urban or rural. But also there's some studies that do workplace, non-residential. And so, I mean, think sort of like anecdotally of 4 places of the home, work, maybe child's school, often maybe place of worship if you go shopping as part of that daily routine or weekly routine. And so there may be non-residential places where these boundaries should be built off of as well. So that boundary column is really sort of how we see the modifiable area unit. And then within metrics, we have a multitude of metrics of how we think the food environment should be defined. And that is sort of how we can see we're not entirely sure how the individual interacts with that food environment, right? What's the context of which the individual interacts with the environment that we've defined in terms of the UGCP. So we have a bunch of different measures there. Our approach, we'll take this approach on the next, is to think about, okay, well, the objective is if we have these multitude of measures and also different boundary definitions, our first step is to define these different boundary definitions and compare sort of traditional store metrics in terms of store densities, a retail food environment, similar to Cooksey and Stowers, but we use the modified food retail environment because in the retail food environment, grocery stores are the denominator. So if an area that we've defined doesn't have a single grocery store in it, then it drops from the sample. So the modified uses total stores as the denominator, so we can keep all of those. And once, hopefully in the next day or so, I get access to IRI point of sales data in NORC, we'll be calculating affordability measures to compare across these boundaries as well. A new sort of relatively novel is that we can see the proportion of events and expenditures that occur that a household has within a boundary. And so we can use that to think about how much is the individual actually interacting with the boundary or the food environment definition that we've defined in that way. Perfect. Thanks for clicking through, Shelley. So our method or approach to thinking about that is we've defined 5 boundary definitions. The first is a common administrative boundary in terms of the census tract. Then we have 2 Euclidean or straight line distance boundaries. The first will be from the SSU or the census tract center of a household 75th percentile of the distance to purchases from that secondary sampling unit or census tract. Then the same Euclidean primary store approach, but using the 75th percentile to the stated primary store rather than of store purchases. And then 2 relatively more novel ones in terms of using a service area approach. So we'll use the distance to purchases and the time to purchases, but have that follow a road network rather than similar, just a simple straight line distance. So then within each of those 5 boundaries, we'll use the USDA food apps to construct the distances to purchases. We'll use TD links to get store counts. And then we use the IRI point of sale data to think about the affordability measures in the future. Perfect. So the next 3 sets of slides are just sample boundary maps. And so they don't actually represent any of the households in food apps. They're simply just a mean measure for rural households to sort of get a picture of representation. But basically the takeaway in each of these 3 is that our census tract, for whether it's rural, urban area or urban center, is much smaller. The Euclidean distance measures are going to be the largest across the 2, and then distance and time for rural, they're not very different in terms of the purple and the blue. But if we click through to urbanized area or even urban center, those purple and blue, the distance and time, end up being very different. And so the definition, in addition to impacting how we think about a food environment, can impact different types of food environments in terms of rural, urban area, urban center differently, in addition to just the definition changing. So those are just sample maps. I see I'm already at sort of 10 minutes, so we'll get to the outcomes, the results. So essentially here, since there's 5 boundaries we're comparing across, A, B, C, D, the little letters on the end, A is always going to denote in these tables that that is statistically different from the census tract mean, B from the straight line, C from primary store, and D from the service area. So in general, what we end up seeing, and you'll see this trend throughout, is that census tracts are statistically different from pretty much every other boundary definition. They have lower store densities, and in general, all of the non-service area by minutes have less healthy by the food retail environment index food environments. That's a tough measure because we have to define a whole store as healthy or not healthy rather than in terms of food environments. But essentially, if we look at the relative measure in the food retail index, households, if we think about the service area by minutes being households being able to and selecting out of their very localized food environment, right? They're choosing to drive by the road network or to a different food environment. With the food, we can think about the relative measure being households selecting into healthier food environments when they go shopping shopping. So if we allow that food environment to expand, allow for households to think about being mobile, they're actually selecting into food environments that are healthier, given that the interpretation of this food environment is a proportion of total stores in that boundary that are considered healthy. So we've also split this up by rural, urbanized area and urban centers. I've just included rural and urban centers here in terms of thinking about the contrast. But in addition to sort of decreasing variation, because now we don't have all types of households, we've also reduced the number of observations significantly by breaking these down. So there's less, I'd say there's less statistical significance across the boundaries, but some of the trends that we see in the full sample still persist. Mainly that's if we allow households to leave their immediate residential area in terms of the census tract and travel by the road network, we see an increase in the healthiness of the food environment, an increase in the food retail environment. And we also see increases in store density. So that's not surprising, but households have to go to areas where there's a higher concentration of stores per population. So I think, well, slightly more interesting, although the other is also interesting, is looking at the proportion of events and purchases that are within particular boundaries. And so what we see for events, again, across the board, it doesn't really matter about store type. We have 3 food at home store types and 1 food away from home store type. The C in there is for consumption, so food consumption away from home. But census tract is also very limited in terms of what I'm deeming interaction with an individual. So a low number of event purchases, a low proportion of event purchases in the census tract compared to other food environment boundaries. If we look at sort of all purchases for all geographic types, right, it's only around 14%. It increases if we only look at food at home types, but that makes sense because we've centered all of these 5 boundaries despite letting the definition change around the residents. And then food for consumption away from home is pretty low across the board, although there are differences by rural and urban center, whereas rural households, if we look at close to them, seemingly rely more on smaller grocery stores. Whereas there's a higher proportion of expenditures and events for urban centers at large grocery stores within the census tract. So we can kind of see, if we allow this boundary definition to differ, we can see a little bit better how individuals might interact with different types of stores within their boundary definition. Sure. That was a lot, really fast. And so I guess essentially the conclusions, the takeaway I would say is that I think census tract definition is limited. It seems to have lower store density and less healthier food environment compared to the other definitions that we've investigated. And it only accounts for about 14% of events and 15.5% of expenditures within the food apps household. The Euclidean line, the straight line, both of those measures are relatively similar. There weren't very many differences between the two. And if you look at the maps, they also looked very similar in terms of shape and distance. And then I think the service area methods, going by the road network, has a better opportunity to capture how households are actually interacting with their food environment. Perfect. And then just in terms of like 30 seconds of the next steps we'll go through with this is I need to sort of calculate the affordability measures, which will add a nice another dimension to looking at these differences. And then check how the measures that are calculated by boundary definition alter or see if they're robust in terms of outcomes, in terms of diet quality with HEI and obesity. Right. Try to talk as fast as possible, Shelley, but I still want a minute and a half over.
That's good. No, thanks for the great presentation. And I'm going to stop sharing my screen and let, hopefully Chen, our next speaker, will be able to share his screen. And Chen is looking at different policy simulations and food demand. Chen, let me know if you need help too.
Okay.
Yeah. There we go.
Did you see anything?
Yep.
Oh, okay. Okay, let me see. Hello, everyone. So thanks for coming to the virtual presentation. So if you look at so I'm going to do this a little differently today. Instead of focusing on the findings, I'm going to spend much of the time sharing the struggles that we have to go through. And this project probably started in 2015. And one way to look at how long this project took is to look at how many farmers we have. 4 out of the 6 authors are formally affiliated with either ERS or UGA. So that tells you how long this thing took. So here's the disclaimer that the research, what I said, doesn't represent the views of USDA. And also another way to see how long this project takes is to look at the number of founders. And we started with Robert Johnson, and then later we added in ERS support, and then we got NIFA support. So that's just how much effort and work went into this project. So what's the economic issue? The economic issue is that we are interested in, again, simulating the impacts of economic incentives and disincentives. And in the US, we have the incentives could include fruit and vegetable subsidies, what's the impact on healthy eating. And the disincentives will be the soda taxes. That would be the most prominent example. Currently in the US, we have seven US cities, and then you plus the country of Mexico. And I think a few European countries also have some sort of the soda tax. So those will be the examples, prominent example of economic disincentive in terms of encouraging a healthier diet. So the issue with the literature is that if you look at most of the simulation studies, they assume homogeneous preferences. By homogeneous preference, I'm not saying that people are assuming different households consume the same baseline amount of soda or fruits and vegetables. I'm saying that most of simulation studies assume the price elasticities are the same across different types of households. So here, the goal of this research is to use food apps data to estimate a complete demand system and test whether price elasticity are indeed different across different types of households. And we focus on households with obese members and households without obese members. The reason for doing that is most of these incentives and disincentives are focusing on combating obesity. But if obese households respond differently to these incentives, then we might want to have a more nuanced policy in order to have a more effective outcome, a policy. So that would be the motivation for looking at the heterogeneity issue in demand analysis, in this analysis. So our approach is use the econometric simulation approach. So what is the econometric simulation approach? This approach is basically you take a secondary data, you fit the data into a demand system model. You estimate all the parameters controlling for all sorts of endogeneity, and then you get to the price elasticity. And after that, you use the price elasticity to simulate whatever price changes you want to look into. And the difference between this demand system and the previous ones, one of the main differences, we actually estimating a complete food demand system that include the food away from home. Most of the demand studies that use scanner data or any other surveys ignored food away from home because most of the surveys did not do a good job in collecting food away from home data, with the exception of food apps. So that's a reason why we focus on food apps. Another reason for using food apps is they have the data set, ERS has already linked the nutrient data with the UPC data, and that saved us tons of work in terms of the data linkage. So the technical challenges, these 4 challenges are what took us 5 years to get to where we are today. So the first one is the level of aggregation. So when we started the project, I was thinking to estimate a very disaggregated demand system where I separate the sugar sweetened beverages into carbonated soft drinks as one category, and then sports and energy drinks, and then fruit juice. So that's used to be the way we separate them using scanner data. But the difference there is that with the scanner data, we have hundreds of thousands of observations. But once I started using the same scheme of classification in food apps, remember food apps, we only have 4,826 households reporting only 1 week of data. Once I estimate a very disaggregated demand system, I end up having too few positive observations per category to reliably estimate some of the demand curves. So I end up having quite a few categories having positive own price elasticity. So instead of concluding that we found some given good, we were stuck here for about 1.5 years, figuring out what's going on. And finally, we found the reason was that we have too few positive observations to reliably estimate the demand curves. And when we have a solution, I will talk about that. And second is the price indexes. There are not enough price information in food apps for the items not purchased. This is intuitive. If the item is not purchased, they are not reported. The expenditure on them are not reported in food apps. So you cannot construct a price measure for those items. But it is important to account for the items not purchased for the household with all the censoring and counter solution going on. So how do you construct a price index accounting for the items not purchased? So that's our second challenge. And third challenge, how do you construct a pricing instrument? So the reason for prices to be endogenous is that I always tell my students that, and the example is, for example, if I'm very obese and I like sugar sweetened SSB, meaning sugar sweetened beverage, very much, I may be more likely to seek lower prices. I spend more time searching for the lower prices. So the prices I end up reporting is lower than the average. So what that does is to make the price endogenous with demand. So in micro data, that's the primary source of endogeneity, I think. So we need to create a price instrument to control for that. And lastly, the question is, do we need to account for the complex survey design? And if we do, the more traditional approach of Taylor series expansion or the replicate weights method, it doesn't work in demand system. I'll explain why it doesn't work. So in terms of aggregation, so our solution is to aggregate the food at home items to 9 groups. And for each group, then we separate them into a healthy category and a less healthy category. And to do that, we scored each item's healthfulness based on guiding star rating. A guiding star is a shelf nutrition labeling program that started with Hannaford. So that's a similar, another nutrient profiling algorithm, Newell, that no longer exists. So we use a guiding star to separate the items. So in total, we end up having 18 food at home categories. And then we added, we grouped all food away from home items into a healthy category and a less healthy category. Again, scoring each food items based on using the guiding star algorithm. And this turns out to be the right level aggregation, and further disaggregation just create too much trouble, and for the reason I elaborated. So for price index, here's the issue. 41%, I didn't realize this until we looked deeper into the data. 41% of food at home expenditures in food apps are on items not reported with a barcode. So this could be either these items are random weight that didn't come with a barcode, or somehow the respondent didn't report the barcode. But 41% of expenditure didn't come with a barcode. The problem with this is if you want to create price index using barcode level data, you're going to miss 41% of the expenditures. That's something you don't want to do, because then your price index will not be representative of the purchases. And then among the barcoded items, 57% can be found at the InfoScan store. InfoScan is the IRI scanner data that you can use to help filling the missing prices, but only 57% can be found in the InfoScan. And overall, 50% of all food at home expenditure were made at InfoScan stores. So again, you only use the retail scanner data for 50% of expenditures. So this tells you that we cannot construct a price index using barcode level data. So the next level is the USDA food code level. So at the food code level, 76% of the expenditures can be linked to InfoScan based on the food code. So this is a level at which we decide to create the price index. So we create each elementary product is a unique food code, not barcode, food code in the data set. So we use the same store or same county InfoScan prices to fill in the prices for the item not purchased. And for the item purchased, we just use the reported prices. And the reported prices, we realize that could be endogenous, and we'll later create an instrument to control for the endogeneity. And then for each of the 18 food at home category, we actually create a Fisher ideal sub-index using the InfoScan for the subgroup of items that we can link to InfoScan. And for the item we cannot link to InfoScan, we just use the food apps purchases only. And then we finally combine these two indexes into a final index for demand estimation. So this took another year to figure out. And then third one is the price instrument. How do you create the price instrument? For the scanner data-based sub-index is more straightforward, because we could just use either the same chain in other counties, or or simply other counties for the purchases at non-IRI stores to instrument the prices. The idea is that assuming the demand shocks are not correlated across counties, and you can use other counties to instrument the prices. And then for the portion that's based on solely on food apps data, we have to rely on a regression approach. And that approach is we regress the item level prices on household fixed effects, on food code fixed effect, on PSU fixed and week fixed effects, weighted by the budget share of that item. And then we purge the quality aspect of that price. The quality aspect is partially captured by the food code fixed effect. So the household sub-index end up being the sum of household fixed effects, the PSU fixed effects, and the week fixed effects. And then you can create an instrument using the same regression where the instrument is the sum of the PSU fixed effect and the week fixed effect. What's missing here is a household fixed effect, because the household fixed effect captures the household preference for certain food. That's the endogenous part that we worry about. So this regression helps us to purge a part of the endogeneity that we're concerned about. And then we combine these two instruments into a single instrument for the demand analysis. Just a second. Hey, Shelly, how much time I have?
I'm not crying yet, but
okay.
getting the tears are starting to form. You're right about 15 minutes. So.
Oh, okay, good. Because I don't see your emoji.
I know the plan may have failed.
Okay, give me 1 more minute. So
Sure.
the complex survey design, we end up using a bootstrapping method. We actually estimate the model 4,000 times. So it end up taking about 3 days to estimate each version. For the full-blown version, we use the easy demand model where we interacted the obesity dummy with the prices and the income. So that gave us a full range of flexibility in terms of we can make the price elasticity very flexible. So here's a summary table of the nutrients per 100 gram of food. The take-home message from here is that although we hope to see that, we probably expect to see that obese members, households with obese members purchase less healthy, but if you look at the nutrient and food, nutrient factor level is not consistently so. Although if you look at the healthy eating index, the overall healthfulness, we do see obese households purchasing less healthy than the household without obese members. So here's the elasticity estimate. I won't spend any time on this, except you see here the beverage star. I'm sorry, just go back. The beverage star category. That will be the healthy beverages. We see household without obese members, they are less responsive to price changes than household with obese members. And here's the simulated changes. This is a 1 penny per ounce soda tax. And this is a 30% discount of fruits and vegetables. And we do see some large differences. And here's the conclusion. And conclusion, we do see a lot of heterogeneity in terms of the price responsiveness, and that translates to different magnitude of impact from these pricing policies. And also we found it is essential to account for the complex survey design, even in the food demand system models. So, okay, that's it. Thank you. Sorry,
Forgot to hit the unmute button. Thank you, Chen. Our next speaker, and Ricky, let me know if you need help, but our next speaker is Ricky Volpe from Cal Poly San Luis Obispo, and he's going to be talking about the local food environment, grocery purchases, and diet quality.
Okay, I think we're okay as long as everybody can see my slides. I'll go into
so far, so good.
All right, great. Thank you all for tuning in this morning. This is a more robust attendance than I'm used to at AEA meetings, even in person. So this is great. And I'll also just say, I really enjoyed the two presentations that came before mine. This is quite possibly the most cohesive session I've ever been a part of in AAEA in terms of the papers complementing each other and covering the same spiel. I know I only have 15 minutes, but I can't resist sharing the anecdote of the time that I was presenting at the Southern Econ meetings, and I got put into a session on risk management somehow when I was presenting ERS work on how people choose their supermarkets. And you know, I kind of tried to be funny and tie it into risk management, and you know, didn't go over so well. But anyway, this is great. This is going great. So I want to acknowledge my my co-authors, Xiaowei Sai, Marilyn Seng at Cal Poly, and Eliana Zabalos from USDA, who I believe is on the call. And this is research that primarily relies on the restricted use food apps data, looking at the local food environment and how that interrelates with food choices. And much like Chen was saying, this is a project hasn't been going on since 2015, but it did start in 2017, and it's been a bumpy road, but we're finally getting somewhere. You know, there's been issues with data access. I actually presented work from this cooperative agreement. Here's a disclaimer acknowledgements. I presented preliminary work from this cooperative agreement 2 years ago at the AEA, and just for a number of reasons that ended up not really going anywhere, and we repivoted. But I'm excited about this. I'm excited to share it to you, and if we have time, I'm excited to hear back from you, any ideas or questions you have. And I just want to encourage, I know we're kind of short on time, we're on Zoom, but you guys all have my email, and if you want to talk about this or whatever, just shoot me a line. I'm happy to hear what you think. So our goal here, yep, it's another food environment paper, and I'm fully aware, and I'm couching this our whole idea behind doing this paper is, you know, we're all as a research team well aware that most papers that study the relationship between the food environment and food choices find limited effects, small effects, largely insignificant effects. There are exceptions, but that's generally how it works in the environment literature and the access literature and the supermarket intervention literature. I mean, I've contributed to some of that literature. So our goal here was to build a novel data set that combines the restricted use food apps, which I think everyone here is familiar with, and how it gives some real advantages over household scanner data. But you know, you have the food at home, you have the food away from home, you know, you have the format choice, you have great demographics, and you have a data set that oversamples low-income households, SNAP eligible households, so on and so forth. And so our goal here was, rather than kind of looking at the food environment, let's look at a really kind of, I don't want to say comprehensive, but a deep dive in an examination in how the food environment has changed, and see if that helps to form expectations about household behavior. See if there's some relationships between households' food choices using kind of broad strokes, you know, buying fruits and vegetables, buying sugar-sweetened beverages, and how they may relate with the trajectory that the local food environment has taken. So I'll get as far as we can, and like everybody, when Shelley starts crying, I'll just go to the end. Okay, so this is, I covered this. There's a long literature that informs ours. Most of it finds, in most cases, there are some significant effects. The effects tend to be small. And the takeaway, which is something that I kind of tend to agree with, is that, you know, if you want to understand people's food choices, you need to understand their preferences. And, you know, addressing the food environment, addressing food access, addressing food prices, that's all one thing. Actually getting in and addressing people's preferences is a whole other story. That's just kind of where we're at, right? And so that leads to the question, what some of you might be thinking, why are we even bothering? And kind of like I said, what I think we're doing that's at least a little different is we're not focused on how things are, we're focused on how things have changed. And as you will see, you know, our measurement of change over time is not a simple percent change. Oh, the number of supermarkets within a certain radius has gone up 5%. I actually want to acknowledge my friend, Patrick McLaughlin. He's an ERS economist. And he actually he came up with this idea when we were spitballing over beers at AEA sometime years ago. But the idea is, what if it's not just the actual change, but the nature of the change in the food environment that helps to tease out, you know, kind of capture what is happening locally, and what impacts might that have on people's format choices and food choices. So we'll see where it goes. And what's also nice about, for this paper, where this is kind of a step above in terms of precision over work that I've done in the past. Every household has its own unique food environment mapped out, because the location of outlets, according to the various channels and formats, are based on the geocoded distance from the individual households in the data set. So there's no assumptions about, oh, let's define, you know, counties as markets, let's define MSAs as markets, which is the kind of work I've done in the past, and we always run into problems, rightfully so, over the issue of market definition. And I'm not saying that this is perfect, but at least we know what are these distances between these respective households and the stores at which they're shopping. Okay, so the data, and the fact that we're combining these three data sets, and we needed access to the food apps and the TD links, and we needed a lot of help from ERS when using the recount data. Recount data, I've never seen the raw data. My understanding is it's kind of impossible for me to access the recount data, but my ERS colleagues can speak to that. At any rate, we now do have this very powerful, very granular data set that combines the food apps restricted use data. A lot of you know what that is. It's about 5,000 households, a lot of great demographics, where they shop, what they buy. And then we use the recount data to geocode the locations of away from home, you know, quick service and full service restaurants. And we use the Nielsen TD links. I think, I could be wrong, but I think if you Google TD links USDA ERS, I'm still listed as the point of contact for that data set. So this is a data set that I know pretty well. And this is a really powerful, comprehensive kind of universe of grocery stores, supermarkets, supercenters by format across the US. So end of the day, we put it all in one place and combine the household locations with the locations of all these food away from home and food at home establishments. For now, and this is a place where we might get a little bit more flexible, but you know, hearing someone like Jen talk about what they're doing just kind of scares me. So I don't know how far down the rabbit hole we're going to go in terms of determining food choices and looking at healthfulness and everything. Right now, our two key measures, we have expenditure shares in the food apps data for 2012, 2013 for fruits and vegetables and for sugar sweetened beverages, right? And I won't mince words. I mean, this is largely out of convenience, right? We wanted to have two relatively large expenditure shares where one is kind of unambiguously healthy and the other is kind of unambiguously unhealthy, right? And that's kind of the idea, using these effectively as proxies for understanding how food choices and therefore dietary quality might interrelate with how the food environment has evolved or changed and the nature of that change. Okay. So in food apps, we actually have variables for each household, which is the distance in miles to the nearest supermarket, superstore, convenience store, the Walmart, and grocery store, other format combinations, which I might need to dig into this a little bit more. My understanding is that last category must be non-Walmart if Walmart is broken out as its own category. So we have that in food apps. And then in Recount and TD Links, we have by year, we have, I really want to thank my colleagues at ERS for coming through with this, because these are calculations that were made at ERS and then made available to us via NORC for us to merge with the food apps data set. By household and by year, we have the count of quick service and full service restaurants, as well as supermarkets and supercenters within these radii. I think the plural rate is radii, these radii around the household. So, you know, for example, for 2002 all the way up to 2013, we have the annual count of the number of quick service restaurants within 1 mile of every household. So that's one way that the data are cut. So we have these defined radiuses, radii, we have these different formats, and we have these counts per household and per year. Okay, so this is where, it's where I think our paper is maybe a little bit innovative, but I'm not gonna spend a lot of time on this, especially because, spoiler alert, we ended up not really finding a particularly interesting variety of results according to the nature of change, at least not in our current regression setting. If I have time at the end, I'll talk about how we're thinking about re-specifying our regression, which may very well be misspecified. But we relied on basically a lot of research in kind of geography, like the geography literature, which required a little bit of, it took some time. It took some time to understand what they were saying and why they're doing what they're doing, but we came up with a bunch of classifications of how we might describe the nature of change in the food environment. So what we did was for every format, right, for every one of those 4 formats and for every radius, we say that the food environment fits into a certain bin, right? So first and foremost, the count within a given radius, it either increased, it decreased, or it didn't change. We use 10% as that threshold of whether or not it increased or decreased or stayed the same. And then assuming that it increased or decreased, there's exponential increase, explosive growth, linear increase, steady growth, diminishing increase, meaning it's going up but at a slowing rate, which we tend to think of that as maybe that's like a maturing environment, right? That environment is getting saturated, which is kind of the opposite of the exponential increase, where that's wild, right? That's gentrification, that's population explosion, whatever's going on. And then discrete increase, which actually happened quite a bit, which is where most of the change is kind of explained by 1 year, where a supercenter opened or 2 supermarkets opened or whatever, right? And then within no change, I think this would be interesting, but so far it ended up not being interesting. There's literally no change, where it's kind of flat over time. And then there are a number of markets where they started here and they ended here, but they had a wild ride, in the ensuing decade. And there was a decent amount of that. So these are the bins we're at, and I'll be, completely forthright and say I think we have more work in terms of fine-tuning our estimation strategy, and our identification strategy for teasing out how these might affect. For now, let me just show you some stats and talk about kind of some of the insights we've gleaned so far. Okay, so despite the fact that, I think our empirical strategy is relatively simple, there's a lot of moving pieces, right? So I thought one nice way of illustrating what we're learning is simply looking at the averages for fruit and vegetable share and sugar sweetened beverage share for a number of these bins just for supermarkets. So you guys can see this is just supermarkets for the supermarket defined radii. We could also show this for super centers, quick service, blah, 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 blah. But here I'm just going to show you for supermarkets. And I have to go through this fairly quickly, but basically, for the most part, these results don't really meet our expectations for the smaller radii, for 2 or 3. And you can see that because I'm really focused primarily on the red line. And we can talk about sugar sweetened beverages in the questions, or hit me up on Zoom or email, but I'm going to, because of my limited time, I'm going to focus on fruits and vegetables, because so much of our policy and public health interest as economists, as social scientists, is just trying to get Americans to eat more fruits and vegetables. And so I'm looking at that red line, and you can see, perhaps contrary to expectations, the red line is relatively low for places where we've seen steady or even explosive growth in the availability of supermarkets. And it's actually relatively high in places where supermarket count has gone down, right? So that didn't really meet our expectations, okay? And it was kind of the same story here for supermarkets within 3 miles. So basically the bottom line here is we're not really picking up on anything particularly interesting or within expectations for supermarket counts near to where people live. And across the households in food apps where we see a lot of variation here, these are perhaps not surprisingly largely, urban, in urban or suburban areas, right? But then when we flip to looking at supermarkets within 9 or 13 miles, right? So we're looking at how the availability or the presence of supermarkets within these wider radii change. Now we're starting to see results that are kind of more what we were expecting, particularly for fruits and vegetables, right? Because you can see as the count of supermarkets goes up in a big way or in a linear way within 9 miles, within 13 miles, that's where we see, even though it's all relatively weak, the strongest purchases of fruits and vegetables, right? And then in the markets where we saw the count of supermarkets go down, we see the lowest purchases in fruits and vegetables. So that was kind of encouraging, and I can already see that I'm almost out of time. Bottom line is, I think what we're picking up on here, and this is something that both of my colleagues today have talked about here, is probably the importance of the rural-urban divide, right? And we have not done a good job of interacting our food environments variables with the urban-rural divide. That's what we're actually currently working on, like literally today. So I'm almost out of time, but I've kind of showed you what we're doing and some interesting results. I'll just, we threw everything into a regression. Right now it's pretty simple. Some might even call it kitchen sink, right? And I think that's leading to some weird results. But I'll just focus here on what we're teasing out on that's fairly robust to that 10% definition and seems to be true across our different radii, right? We do find that supermarket decreases at wider radii, so this is probably relevant to more sparsely populated rural areas, are associated with lower fruit and vegetable shares. And in more urban areas, right, where we see supercenter decreases within relatively close proximity, we see that associated with decreased sugar sweetened beverages. And that's something I know a little bit about. Actually, the paper that I published during my time at ERS that I'm most proud about looks about what are the potential determinants of why people tend to buy less healthy foods at places like supercenters, right? So we have these two results that are kind of true throughout our regressions, and they meet our expectations. We also have a handful of results that we really can't tease out. And to be totally honest, most of our food environment variables are insignificant, even if the signs are in directions that we tend to think make sense, right? So that's where we're at. I'm going to stop because I'm easily out of time. I don't know if the slide, this is recorded and I think the slides are being available, but we're at work on trying to improve our estimation strategy. It's been a fun project. It's taken a lot of time, but we're finally getting there. And I thank you all very much for your attention.
Thank you, Ricky. I'm shedding tears of joy because your consideration of timeliness and a beautiful presentation. Okay, so our last speaker is Mary Muth from RTI, and she's going to be talking about some work she and her colleagues are doing with at RTI, and looking at some of the results they have for looking at the IRI scanner data and some important measures on the food retail environment. So Mary, I'll turn it over to you and let me know if you need help. Looks like you're good. If you unmute yourself.
Yeah, I have to unmute first. Yeah. So did it come up all right?
It looks great. Yep.
Okay, great. Thank you. Yeah, and thank you all for joining. It's great to see everybody online, and great presentations. They are a very cohesive set. So I'm going to be talking about some work that we've been doing for ERS, and I want to acknowledge some of my co-authors, Sean Carnes, who's a superstar data analyst at RTI, Saki Kinney and Peter Siegel, who are statisticians at RTI, and then Chen Zhen at University of Georgia, who worked with us on the price and aspect of this project. So first, want to acknowledge funding from the Economic Research Service under contract, and that all of the views expressed here are those of the authors and should be attributed to ERS or USDA. So the overall objective of this project was to develop data resources for researchers to use while analyzing the IRI InfoScan store data acquired by ERS. So our project is, for this part of the project, it aligns with the timing of the Food Apps 1 data collection. So it's developing some tools that can be used with the Food Apps 1 data, but similar efforts could be applied to Food Apps 2 when that's fielded a couple of years from now. So it's kind of setting up some of the methodologies that could be used for that aspect. So we have 3 activities. The first is constructing store level weights for use in analyzing InfoScan data, and I'll talk a little more about why that's necessary. When ERS acquires data from IRI for the household panel data, consumer network data, weights are provided with the data set, so you can weight up to a specific geographic area. The IRI will not release weights for InfoScan data, so that's the reason for our project, to estimate those. The second activity was to map the product codes within InfoScan, including both the barcodes and the random weight codes, to the new ERS food purchase groups, which hopefully most of you have seen those, are familiar with those. And then finally, we're constructing weekly store level price indices by those ERS food purchase groups. And so that gives researchers flexibility then in using those store level price indices and combining them to different geographic areas of interest for their research. So these can directly be used with the Food Apps 1 data, but could also be used for other purposes as well. With the basic idea that they could be used like in the prior slides we talked about, and looking at the effects of the food pricing environment on household food purchases. And I guess one other thing I wanted to mention is that for Food Apps 1, there were also some similar geographic price measures that were constructed. They were based on the Thrifty Food Plan groups, and they were constructed, I believe, as average prices rather than price indices. So there were some similar tools that were available, that are available already for Food Apps 1 data. Okay, so we talked a lot about InfoScan at this already, so maybe you all are familiar with this, but I'll go ahead and talk a little bit about the InfoScan data itself. So it includes store level weekly retail sales by product code, and by product code I mean both the barcodes, the UPC codes, and the random weight codes. And so it includes private label products and random weight products for some of the stores and branded products for all stores. So some of that is based on, not all store types would have those types of product sales, but some of it is just an issue about whether or not the data reported to IRI, and if IRI releases data ERS. It comprises all types of retailers that sell foods and beverages. So the data fields are UPC code, a store ID for the store level data, but many of the retailers report at what's called the retailer marketing area. So stores are grouped and aggregated so that to preserve some of the confidentiality of the data from their perspective. We have week of the data, number of units sold, and total revenue in dollars. So the store level details is really useful for characterizing the food environment. But as I mentioned, ERS doesn't have access to weights to weight that data up. You can't actually calculate subnational or national estimates of sales of particular food products given how the data are provided at this point. So for our weighting, and I have Saki Kenny is a very competent statistician who is not here to present this, so I'm doing my best to represent her. So in terms of how this weighting is done, it's different from typical survey weights because it's a non-probability sample. So first we had to do some data preparation steps. First was disaggregating those stores that report at the RMA level. And we actually allocated proportionally based on total sales and TD links. TD links just has one variable that represents total sales, and part of that is food and beverages, and part of it is all of the other consumer products that those stores sell. We talked already about TD links, so I won't say a lot more about that, except that it's sort of believed to be a pretty comprehensive data set of all retail establishments in the US. And then we had to do some imputations in cases where, for whatever reason, in the data that ERS has, there were no private label or random weight products. So we did some imputation to calculate values for those stores where we believe that they have those types of sales, so that we could get a true estimate of the total foods and beverages for each store in InfoScan, which is also another variable that will be made available when we finish all of these development of all these tools. So here's a comparison to show you what the IRI data look like compared to TD links. These are data for 2012. Again, we're trying to line up with the year the Food Apps 1 data. And we're actually in the process now calculating similar weights up through 2018, and hopefully we'll do later years going forward. So this gives you a general idea of sort of how representative or how complete IRI data are relative to TD links. A lot of the differences that you see here are like for convenience stores. A lot of what they label as convenience stores don't have scanning capability, so there's no way to report the data. Others are just, it's a matter of what data, what stores actually participate with IRI and their reporting, and then again, out of that, what IRI is able to release in the data sets to ERS. So this gives you a sense anyway, if we believe that TD length is pretty close to the population, we need to figure out a way to weight the stores showing up in the IRI count to get up to a national estimate or a subnational estimate. So we were calculating control totals for the weighting procedure. So part of that is selecting geographic regions to use for the weighting. So we're basing this off of the top 10 metro areas in the United States, and then remaining stores that are not in one of those metro areas are being assigned to their census region. Essentially, we have 14 different geographic areas. And the control totals then are calculated by summing up the imputed sales within each store type and geographic area. And then the multiple imputation method is used to estimate food and beverage sales from total sales for developing those control totals. So for the weighting procedure, so the goal is to create a weight so that the weighted food and beverage sales estimates and the weighted store counts match the control totals. And it's using a method called, it's a generalized raking procedure, also known as iterative proportional fitting. So it develops initial weights and then goes through and does a raking procedure until it recreates from the controlled totals to the totals that we're trying to match to. So again, this is a method used for non-probability samples, and I'm stumbling through it because I'm not an expert in this approach, but I guess the important thing to understand is that it's a method that you use for non-probability samples after the data are collected, rather than creating a nationally representative sampling process for a survey. So, so this is what the resulting data set will look like. We have a draft materials already developed that will be reviewed. So we'll have like each store ID, the industry channel, the geographic area code that it's been assigned to, and then our estimate of this total food and beverage sales based on our imputation method, and then whether it's stores in RMA, and then finally the weighting factor that can be applied to that store if you're trying to develop a total estimate of sales for a particular product in a particular geographic area. So basically, to use that weight, you would just you would multiply the weight by the sales estimate, sum over whichever stores that you're including in that area. And the weights can also use to compute standard errors and to perform other analyses. So you could use those weights in a weighted regression using standard statistical software packages. So I'm going to move on. Well, first I'll mention some of the limitations. So it's a pretty tricky procedure to do all of to do the imputations and then to get everything to converge. So, and one of the issues is that really the weights, if you're trying to use the weights to estimate a sub-national area, in truth, they should really just be applied to the metro region geographic areas that we've defined, either one of those top 10 metros or one of those census regions. If you use it for smaller geographic areas, it could cause misleading results. And we had investigated trying to do more refined geographic areas, but we run into issues with not enough stores within certain cells in the info scan data. So this is the closest we could get it. Yeah, so there's limitations then just in terms of the info scan coverage of stores in certain areas. Our method of allocating stores to RMAs could potentially be inaccurate, but we thought that was the best approach in terms of doing it proportionally to the TD estimates. And then finally, as you all probably know, any of you who work with InfoScan data, it represents larger stores, for grocery stores in particular, those with greater than 2 million in sales. So not having those smaller stores could potentially bias the control totals that we're calculating for the weighting procedure, and it also causes a high unequal weighting effect, which inflates variance. So there's some limitations of those weights, but as we start to work with them, we'll probably learn a little more about how successful they are in generating subnational and national estimates. So I'll talk a little bit about the food code mapping that we're doing. This is a pretty straightforward thing in terms of mapping all of those, the UPC codes and the random weight codes to the ERS food purchase group. So this facilitates grouping products for calculating price indices, average prices, price purchase quantities by types of foods. There's 91 categories total that have been developed in these broad categories like grains, vegetables, fruit, etc. And so for the mapping that we have done in 2012, there's a total of over 500,000 product codes in the InfoScan data in 2012. So the majority of those are UPCs or barcodes, and the others are random weight codes. And from our mapping, we were able to map all but 0.6% of the product codes to an EFPG in 2012. And we started by using mappings that had been done in prior studies for ERS using 2013 and 2015 data. And so I think maybe about 25% or so of the products had not been mapped previously. So we mapped those based on logical assignments, based on the product description fields that are available. So the data set's pretty straightforward. It has the IRI UPC code, which it really, the way they've defined it includes both the random weight and the barcodes. The ERS food purchase group that it's assigned to based on the numeric value for that code, and then just information about how we mapped that individual product and whether it's part of the point of sale or perishables InfoScan dictionary. How am I doing on time, Shelley? I have just one last part of it.
I got you at 13 minutes, so.
Okay,
yeah.
So I gotta finish it up.
Yeah.
Okay, all right, and then finally the price index calculation. So using the mapping that we have developed between the IRI product codes and the EFPGs, we've created store level price indices. And so with those store level price indices, then you can combine them for use in your analysis, depending on how any of these different methods that you might want to use to calculate the environment within around a particular household. So price indices can't, in certain contexts, are referred to unit values because the mix of products within a food group differs across stores and over time. So a higher unit value could reflect higher market prices or a higher proportion of premium quality products. So the price indices help to normalize that aspect and so a little more reliable for some analytical purposes. So we calculated those store level price indices for each EFPG, each of the 91 EFPGs. We included all weeks in 2012. We also included the first 4 weeks in 2013 so that if an analyst is using these price indices with the Food Apps One data, they'll have all the weeks covered. So we added that part on as well. Before calculating the price indices, we eliminated the price outliers using the interquartile method. So basically eliminating ones that are on the far extreme one way or another based on the formula shown. So the ones that are included in the data set include the Lesper's, Bosch, Fisher, Ideal, and Tornquist. So a researcher can choose among these depending on the purpose of their analysis, or if they want to conduct sensitivity analysis to tried to try out different pricing in their analyses. The data set is pretty straightforward as well. So for the data sets are set up with a store week identifier. So each store in the InfoScan data and the week of that that it was calculated for, and then each of the index values. Base is set at 1 for the sample. It's set at 1 at the sample mean for each index. And as it's set up right now, the price indices for each EFPG is in a separate data file. So once with these store level price indices, they can be combined to develop a price index for specific geographic areas in 2 different ways. One would be using the InfoScan weights that we're developing, but those are really only valid when you're looking at analyses for a metro area or for those census regions. An alternative approach would be a sales volume weighted approach, where you're actually developing your weights based on the proportion of sales for the stores within in the geographic area. So in the documentation we're preparing, we'll be talking about those methods. So finally, conclusion and next steps. So we're hoping that these newly created data sets will enhance the utility of the InfoScan data acquired by ERS, and also provide additional data resources for use in analyzing FoodApps1 data. We're in the process of getting an external peer review set up, and then based on how things go with ERS clearance, we're hoping then the report will be available publicly and the data sets would be available to work. So that's all.
Great. Thank you, Mary. Thank you, everyone. So now we have some time for questions, and I want to invite everyone in the audience to either just unmute themselves and jump in if you feel like it and want to raise your hand using the chat button, that's okay too. I know, Chen, I'm not sure if you saw it, but in the chat room, Grace Mello had a question for you, and maybe we'll just start with that question, Grace, if you're still here. And if she's not, I can read it for you.
Yes, yeah, I was, he already answered to me that he was going to answer.
Oh, he did, good.
But yeah, I was concerned since obesity is a variable of interest and he's interacting that with price. And I choose to eat healthy or not. So it's a choice variable. And I was wondering if he's addressing endogeneity that comes from including that variable.
For this problem, we are not concerned about the obesity being endogenous choice variable, because all we are doing is estimating a model conditional on being obese, and then we ask the question: are they going to respond differently to prices? We are not at all trying to get into the mechanism of how they got into the obesity situation in the first place. So that's yeah.
Great. Any other questions from the audience?
Hi, this is Eliana. I have a question for Mary about the TD-Link sales. So TD-Links, I've been working with that data a lot too, and then the sales that they show are overall sales of, for example, a supermarket. And then of that total sales, only a portion is on food. Do you calculate that portion before doing the ratios?
Yes, yeah. We recalculate what our best estimate of what their actual food and beverage sales are at the store level based on the TD-Link state. So if it's a store in InfoScan, we actually just literally add up their food and beverage sales to get their total sales.
Yeah.
But for all of the other stores that are in TD-Links that aren't in IRI, yeah, we use an imputation procedure to try to calculate our best estimate of what their actual food and beverage sales are out of the total sales.
And you
and
don't use what the census gives you, like those proportions that census calculates that are on food.
No, we're using an imputation model with Proc MI within SAS to do that, the imputation. And in an earlier stage of this project, we had actually investigated whether or not we could use Census Bureau data to develop our control totals instead. We ran into a lot of difficulties. We were working within the RDC that's here locally, and there was an issue with the proportion of stores that we could actually match up to their census records. And then the second thing is that based on how things were going, it looked like we would never be able to actually release the weights out of the RDC. So we needed to figure out a way to do it based on data that could be shared.
And what do you do to account for the fact that TD Links changes the way they calculate sales from year to year, and not for all categories, but also for specific establishments? Okay.
So yeah, so we should probably follow up and talk about that, because we're developing weights for up through 2018 now. So if there's things about how TD Links calculates its weights, it'd be good to know.
Okay, yeah, because I had so many problems with that.
Okay, yeah,
thank you.
I'll follow up with you.
Thank you.
Thank you, Eliana. Other questions? Armin.
Thanks everyone for the presentations. Those were really interesting. And I have a question for Chen. So you're calculating whether, you're trying to see whether households with an obese member are more price sensitive, right? To like taxes. So I understand that you had to aggregate data at the household level, but the food acquisitions happen at the individual level. And it seems like your data, your results show that that is in fact the case, that households with an obese member are more price sensitive than those without. Do you think we can expect the results to be even larger in magnitude if the study was done at the individual level?
It might. It's just we don't have a good way of modeling individual level, because you got a primary shopper for everybody. So how do you assign the food to individual members? We don't have a model. Arthur Lubell and others, they have those super sophisticated model for intra-household allocation, but you have to make super strong assumptions on preferences. I don't find it useful for policy purposes.
Okay.
Yeah.
Thanks.
That's a good question. Yeah.
Do any of the panelists want to ask questions of their fellow panelists?
Yes, thank you, Cheryl.
All right, Ricky, thank you.
Yes, no, I do. This question is for Ben. Ben, could you just talk a little bit about the food retail environment index? It's something that before your presentation, amazingly, I'd never seen before. So where it comes from and kind of like the primary roles that it fills in your research.
Yeah, so there's two sort of ways. There's the food retail environment index, and then there's the modified food retail environment index. And I think, maybe others can speak to it, but my interpretation of the modified is really just getting around this denominator problem. And basically, the retail food environment index is, I'm going to name a store healthy or unhealthy, and I'll figure out the ratio of unhealthy to healthy stores. And so the way, I'm blanking on the paper right now, I think Cooksey and Stowers is who used it first in terms of coining the term food swamps. But they sort of like do this weighted of, can you find a certain number of deemed healthy UPCs at a store, and then that'll be a healthy store versus an unhealthy store, and then you create this ratio. The problem, as I sort of said very, very quickly, is that if you don't have any healthy stores in an area, depending on how small or large you're making that area, you suddenly have an undefined, right, index. You have because there's 0 in the denominator. So you don't have an observation necessarily on that. So if you flip it and have healthy, the modified version of that is healthy over unhealthy, and then they actually multiply by 100, but that doesn't really matter, you have significantly less undefined because you're just more likely to have an unhealthy store in an area than you are healthy. So it's really just a ratio of the two to start, and then the modified is actually interpretable as a proportion of healthy stores to total stores. Yeah.
Yeah, cool. I have like a half dozen questions about how that works, but we can just chat later. It sounds like a really good resource.
If it helps at all, when we were sending back drafts, Shelley had a relative strong note about whether that measure is useful or not.
Ricky, I'll get online when we talk and I can rant a little bit, so.
Looking forward to it.
Other questions? I might take a little bit of the moderator's discretion to ask a question of Ricky. I like the concept of, sort of the trajectory of where the retail food environment is going. And I wondered if in some of these areas, it probably doesn't matter, but in some, that part might be endogenous in some ways too. So like if a big, Walmart comes in, let's say, that might impact some stores, and it may, you'll often see Walmarts with dollar stores because they tend to co-locate perhaps, or you might see a smaller grocery store move out of business. And I'm just wondering how you were thinking about that problem.
Yeah, I think that's a great question, and we have thought about it. And what we haven't really done yet, but it's kind of been on our list, was sort of just as a starting point, as in a very descriptive way, looking to see if we can tease out patterns that abide by expectations exactly like what you're talking about, right? And then so looking for evidence for it, seeing if there's this co-movement or these correlations, right? And then yes, dealing with that in a regression framework. But you're absolutely right that I think failing to account for that, which is almost certainly happening, at least in some markets, is I didn't talk about it in my presentation, but we have a few results that just don't make any sense. Like they're positive and significant for 7 miles, and then they flip at 9 miles. And I think that's happening because of a misspecification that's driven in part by endogeneity. So what we really need to do, exactly right, is look at urban, rural, population density and see where those patterns shake out. It's a great idea. And frankly, we still have a lot of work to do on that.
Yeah, we've been struggling with some of the same problems. So
Thank you for that.
Any other questions from the audience? Well, if not, we are right on time. I guess that's a thank you to the speakers for that. I do want to give a few thank yous. First of all, let's all give a round of applause to Mary Muth for putting together an excellent
Thank you.
session. This was really great. So thank you, Mary, and thanks for inviting us all. Also, thanks to the audience. You guys were great. And thanks to the speakers. Thanks to ERS, which had a hand in every one of these presentations. So I know Eliana was here and Christian's still here. So thank you guys. Tell Mark Dembali and all the folks there to thank you as well. And then thanks to AAEA. Dawn was on earlier. I think she's left, but this was, it worked out pretty great. I'm really pleased with this session.
I'm here.
There she is. Yep.
I am just characteristically quiet, but yeah, this is great, and we've continued to be impressed with the involvement. Well over a month later than we would usually be meeting, and as one of your speakers said, in some ways these virtual events have been actually really positive. And actually, meeting with all the section leaders here in a couple hours, and we're going to talk about even if we get to go back to being live next year, if we'll keep some of these virtual events going. And you guys are a great example of why we think we might, just because some of you might not have even been able to make it to an in-person meeting, and there was great participation here. So thanks for being a great example of that.
Thank you, Dawn. Okay. All right. Well, if there's nothing else, I'll give a few seconds for anyone to chime in with anything, but otherwise we'll see you at the next Zoom meeting and hopefully in person very soon.
Thank you, Shelley.
Yeah, you're welcome.
Have a good weekend.
Bye-bye.